I hope you guys are ready for lightning talks. We're going to start with Jeff, who's talking about running wild with Android assets.
Yeah, something like that.
All right, let's see it.
There you go. Hi, I'm Jeff. I work for NCC Group. I'm a consultant. I do hacking things for a living, whatever. This talk about the Android asset manager subsystem that manages all the asset files in the /assets directory. If you reverse or hack on Android apps or stuff, this might be relevant to you. So a while back, I was working on React Native stuff for reasons. Surprisingly, it wasn't project work stuff. But basically, React Native is a framework that's cross-platform, written by Facebook, that basically allows people to write their mobile applications in JavaScript for some reason. And it doesn't actually use web views. They actually embed JavaScript core itself from WebKit and use that as an interpreter. From my understanding, the reason for this is because on iOS there's no JIT, but they also use it on Android. I wanted to modify the JS files that get loaded that are bundled together to add stuff to them, but without modifying the APK. Those files are embedded in the assets directory in Android, which is a special super magic directory in the app that basically doesn't get handled by the class loader's resource stream handling. Android has a separate subsystem to load it out of the base zip itself. So initially, I tried to use exposed. It's the basic thing to do. Java, you just hook the API in the class, and no effect. I didn't even see the calls coming through. Then I realized that React Native is actually largely native code, surprisingly, and uses the Asset Manager C API, funny enough, which is just an extern C wrapper around the actual C++ API that's on the inside. That API is actually used by the Java code from that Android Content Res Asset Manager class. So I had an idea. I wanted to just hook this with LD Frida. I didn't want to use Frida for, I don't know, reasons. I just wanted to mess around. This is easy enough to do for the CPI because you just took you make your binary. It has the symbols for those things. Android has a thing to do LD preload, and you just make sure you use DL open to wrap the calls to pass them through. Normal vanilla stuff. But I wanted to get the C++ API to get both Java and the React Native at the same time. And this is a little bit difficult because while the C API calls to that C++ API happen across a shared library boundary, so they're in the PLT, and you can hook them with LD preload. The C++ code itself is super polymorphic, and any calls inside itself would, or via the vtables, are just direct, and they don't go through the PLT exports. So, and some of the virtual functions don't even have symbol names for some reason, something about inlining. So what do you do in this case? You override the vtable. That's fine and good and all, but with all the different versions of Android and stuff, how do you make sure that across builds this doesn't break? Because the vtable stuff is super implementation defined. It's the compiler. If they ever change that header file, the entire order of all the function pointers in it will change. So I had the crazy idea to actually use the C API to profile the vtable stuff by passing in a fake constructed C++ object where the vtable is filled with a bunch of function pointers that know their own offsets in the vtable. So as I call one by one the C API functions on it, it gives me the offset numbers for each of them. So I built this tool called AssetHook. It's written in Rust for a bunch of reasons. It gives me the low-level access needed to actually create these objects. And also, it has a whole large dependency system that is super great with a bunch of crazy features. And all of that gets statically linked, which is great on Android, especially since it supports various architectures and operating systems, including Android, on ARM and ARM64 or ARCH64. But I also got it working on x86 with just some type punning manipulation. So it basically just does that trick where it profiles the vtable early on by calling the C API. The only weird thing about it is that for the destroy call, I have to use the libc's own malloc because it deletes it, and I can't have it be deleting Rust objects. Things get weird. So it has a check on some of the calls it hooks to basically, if the asset that's being loaded exists under this magic path on the system, it will instead load that file instead of the one from the APK itself. So demo time. Hopefully the demo gods are kind. Yeah. So this is the Hello World app of React Native. It is a tic-tac-toe app where you get to play with yourself, because that's great. It's so fun. I love it. Let's kill that guy. But now I want to change this file. If you can see this, hopefully. I'm changing the, if X wins, it's going to say REcon now. And note, I'm not going to change the APK itself. I'm just going to make this magic little call, which calls some ADB stuff that sets the LD preload environment variable. You need to be root to do that on your phone. You can't just do that through ADB. And then go and, oh, sorry, that's the wrong app. Ooh. There we go. Oh, I did not, damn it. See, this is why I'll just do this again. There we go. REcon wins, as always. So future work, this is like a neat trick and stuff, and probably has its uses, but in the real world, you use something like Frida, which actually writes over the instructions and maintains a whole mapping of the intercepts and everything, so it's all stable and runs and everything. So I want to leverage Frida from Rust to leverage all that static linking and dependency stuff to do all sorts of crazy protocols and random stuff. The safety of Rust is also fine too, but you can actually write a lot of code in Rust that would take like 3 times or more in C++. Only problem is Frida, the actual thing, library that does all that hooking stuff, is C, but with G-objects, glib G-objects, which is this whole massive, complicated, object-oriented macro system thing in C that technically there are libraries for Rust, but they don't allow you to extend, have your Rust code extend the objects such that the C part recognizes them, which is how Frida works. You actually implement an interface in that C code with the G-object stuff to extend it, and then it'll through fake polymorphism call your functions instead. I've got some initial code that works. It's got a lot of shenanigans in it, but basically, if you drop in a libfrida a statically linked archive from the releases page, and also the associated fridagum.h file, it'll wrap the whole thing properly with a little bit of C code and get that all working, and you can actually have your hooks in Rust. Right now, I don't have a lot of state stuff, and it's super unsafe in Rust even, but it does work and basic stuff. But yeah, questions? Yeah. Yep. I was asked to cat my hook.sh. So this basically just does, if you can see that well enough, just some set props. The way Android works is there's this wrap dot, and then you give it the package name, and then you give it an LD preload there, and it all just works. That's how you can. Yeah. So this is because my ADB doesn't run as root by default. I don't like it to do that, so I just add in that. Quirk with ADB, shell with the SU. Technically speaking, there's weird stuff because of the way it passes it in. So this is fine the way it works right now, but sort of most of the time you want to actually wrap it with another set of quotes, because the way it gets passed in, if you had multiple commands, they actually would get run as the normal user because SU would only see the first one. The way it gets passed in is weird. But yeah, this is pretty simple. The only problem is it's actually Bash. I only realized this morning because I was originally writing this on OS X.